Hello everyone, I am Snigdha Kakkar. This is my channel AccelerateAICareers. Today I have brought a very interesting LeetCode problem, LeetCode 47, Permutations 2. We have done a similar question of permutations before, but that was an easy level question. This question is a bit different. I will explain how. Now this question is really important. Why? Because it has been asked by several FAANG companies such as Google, Microsoft, Amazon, LinkedIn, Meta, Bloomberg, Apple in their last 0 to 3 months of interviews. Now, what does this question say? So you have been given a collection of numbers nums, that's an array, that might contain duplicates. So that's how it is different from prior question permutations which we solved. It didn't have any duplicates. Here you might have duplicates as shown in example 1, you have 2 ones. And you have to return all possible unique permutations in any order. So the keyword here is unique. You cannot have duplicate permutations. That's again a point of difference from the prior question. Now let's look at the examples to understand how you will get those unique permutations to return the answer. Now what does permutation mean? When we talk about permutations, we basically have say 3 places in this array. And for the first option, we have 3 choices. Either we choose index equal to 0 position, which is 1, index equal to 1 position, which is 1, and index equal to 2 position, which is 2. So we have 3 choices here. For the next place, we can choose 2 choices since we already made 1 choice in the prior. And then for the next, we have 1 choice. So usually when we talk about unique permutations, we have n factorial permutations or 3 factorial permutations. Or you can say 3 into 2 into 1. That's how we get permutations. But this will not apply here because you do not have unique values here. You have more than 1 values which are same. For example, here there are 2 ones. So in this scenario, you don't have 2 unique values. Rather, you have same value 1. So why will it not work here? Let me show you using a decision tree. Suppose I choose that the first place will have index equal to 0, value 1. Then for the next choice, we'll have 2 options. Either we choose 2 or we choose 1. So 1, 2, 1 or we'll have 1, 1, 2. So we have 2 unique permutations until now. Now say suppose I decide that I will not start with index equal to 0, value which is 1. We'll start with index equal to 1, value which is 1. So instead of this, I will start with the other one. But the same permutations will still remain because the value still is 1. We have other 2 values as 1 and 2. So the permutations will still be 1, 2, 1 and 1, 1, 2. So exact duplicates. And the question indicates you should have only unique permutations. So you will not have 4 permutations here, but you will have 2 permutations here, both starting with 1. Now say suppose we talk about permutations starting with 2. So then we'll have next value which would be 1, another value which would be 1, and we don't have any other permutation because if you say I will choose the other one, but then also your permutation is not unique, it is same as the above. So essentially you will have only 3 unique combinations. Starting with 1 you will have 2 and starting with 2 you will have 1. So that's how your output is shown here, and you don't have 6 permutations here. Instead you have only 3 because of 2 duplicate ones. So I hope the question is clear to you. So how do we solve this? To solve this question, you basically cannot begin with an array. You have to begin with a count hash map where you will have numbers versus their count. So basically 1 has count 2, 2 has count 1. You begin with this. And then you go through this count hash map and keep on permuting with individual unique numbers which are the keys of this count. And keep on doing that until the count of the number reduces to 0. And the length of the permutation which you have equals to the length of this array nums, because that is when you have achieved 1 permutation and you can append it to your result. And that would be our approach to solve this question. The time complexity would be somewhere around O of n into 2 raised to power n. This n, initial n, comes from basically going through the count hash map and then reducing the count again and again. So backtracking, and then 2 raised to power n comes from the permutations which are possible. It could be equal to n factorial in worst case because then you have n factorial permutations. But this is your solution time complexity here. Now let's start coding this question. So to code this, I will first initialize my result array. And then I'll also initialize my current permutations array where I will capture current permutation. And then I will initialize my count hash map where each number's count will be initialized as 0 for n in nums, and then I'll update that count. So to update that count, I'll go through the nums array, and then I'll update count of n and add 1 to it every time I come across that number. That's how I update my count hash map. Now I will write nested depth first search function or backtracking function. I don't need to pass any values through this function because this function is nested function, so it automatically gets all the variables from outside. And I'll take the base case. The base case would be if my length of current permutation is equal to length of nums array. In that scenario, you have obtained a valid current permutation and you can append it to your result. But you are remember you are using the same variable permutation perm for all the permutations. So you need to store a copy of this since it will get modified later on. And then you can return. That's your base case. Now I will go through my count hash map and I will check whatever values count is greater than 0. That value I can append to my permutation. So if the count n is greater than 0, then append it to the permutation, current permutation, and then decrement the count because you have used this value, right? Decrement the count by 1 and then call nested depth first search. So basically, every time you add a value to perm, then you call the backtracking function again, and you will keep on doing this until the length of current perm is equal to length of nums and you have added to your result. After that, only thing remaining is cleaning. So you clean the count hash map because you are decrementing count here. So you have to bring it to the original state. To do that, you will add +1 here. You'll add 1. And also you have to bring perm in current state. So you will have to pop whatever you added to the perm earlier. That's how the cleaning is done. Finally, outside this depth first search function, we will call this function to initialize the backtracking and finding the permutations. And now I know that my result variable will have all the essential unique permutations. I just need to return it. So this is my solution. I will run it. It's accepted. Let's submit. As you can see, our solution is doing quite well here. It's beating almost 58% of the solutions. If you have a better solution to solve this question, do let me know in the comments. I would love to learn from you. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.